All right, Mr. Ahmed here for 9.4. Today we are going to start working with our sine, cosine, and tangent ratios. And the first one we're going to work with is tangent. Now, in order to do these, we really need to have a scientific calculator or a graphing calculator that has these three buttons on it. We need sine, we need cosine, and we need tangent. All right, a couple key things. Even if you have a graphing calculator, before you start, make sure you press mode and make sure you are in degree mode. Okay, so degree should be highlighted, and quit the graphing calculator. That's in the same spot, looks very similar, and you can check to make sure that degree is highlighted. If it is not, you'll run into some issues, and I'll just pull out my graphing calculator and show you how that looks here as well. So if I press mode, notice I have this radian or degree. I need to make sure we're in degree. To get that to highlight, I would press enter over the top of it, scroll over, press enter. Now I'm in degree mode. So moving onward, tangent ratio is for right triangles, okay? It's the ratio of the lengths of two sides in a right triangle. All right triangles with a given acute angle are similar by the angle-angle theorem. So we can use this ratio of the sides in order to find missing side lengths based off knowing one of the angles. So in a right triangle, the tangent ratio is equal to the opposite leg over the adjacent leg. Now, a couple key things here. We have to identify which acute angle it is we're looking from. We never look from the hypotenuse because from the right angle, because opposite of the right angle is the hypotenuse. So it can't be opposite or it can't be adjacent, all right? So when we are choosing which angle we're looking from, typically we're going to work from one where we know what the angle is. So in this example, our reference angle, or the one we're looking from, is angle A, and the leg that is opposite of angle A is across from it, so that's BC, and the adjacent leg is connected to it, that's AC. So we are going to first just practice finding the tangent ratios based off some of our triangles. So the first one says, find the tangent of S and the tangent of R. Write each answer as a fraction and a decimal rounded to 4 places. So we need a calculator. So first we'll do R. Tangent of R, angle R, tangent of R is equal to the opposite over the adjacent. So when I look here, opposite is 18 and the adjacent leg is 80. I don't use the hypotenuse for the tangent ratio. So 18 over 80 is my fraction. I don't care if you reduce that or not, but I'm going to show you how. With the fraction button, 18 over 80 reduces down to 9 over 40. I just typed in with my fraction button 18 over 80. If you're using a graphing calculator in order to reduce the fraction, you would have to type in 18 divided by 80. And then from there, you get a decimal. So you have to press the math button and then fraction. So FRAC stands for fraction. It'll convert it to 9 over 40. And as a decimal, that was already, we saw 0.225, so I don't need to go any further than that. Okay, now we'll look from S. So things change when I switch my reference angle. So now if I'm looking from S, opposite is across, so opposite is 80 over the adjacent, the leg that's connected is 18. And now for me to reduce 80 over 18, we already did that once, so that's equal to 40 over 9. It's just upside down. 40 divided by 9, using my calculator, I get 4.444. And we have our decimal as well. Oh, I made a mistake. No, I didn't. We're okay. All right, I got it right. We're good. All right, next example here. Find the tangent of J and of K. Write each answer as a fraction and as a decimal rounded to 4 places. So first we're going from J. I'm going to do J with my red. So the tangent of J, opposite, go across. Opposite is 24 over the adjacent, 32. Now sometimes I'd label those O and A. Notice I did that with my red pen because that's opposite and that's adjacent. Okay, so 24 over 32 reduces down to 3 over 4. which as a decimal, 3 divided by 4 is 0.75. Now for the other angle, looking from K. Now things change. So opposite of K is 32, and adjacent is 24. So notice how you have to really understand which angle you're looking from. So here, this was an A, now it's an O, was an O, now it's an A. That's based off the reference angle. So the tangent of K, angle K, is equal to opposite 32 over the adjacent 24. That reduces to 4 over 3, which is 1.3333. We carried out to many decimals to try and keep our answer more accurate. Okay? So, next one, tangent of J. We'll write that one up here. Tangent of J, angle J, equals opposite 8 over the adjacent. Make sure you use the leg. The adjacent leg is 15. 8 over 15 does not reduce, but when I divide it, I get 0.5333. All right, now for K, I have to use the acute angle. I cannot look from 90. So the tangent of K equals opposite 15 over the adjacent 8. Does not reduce. 15 divided by 8 is 1.875. And we got it. So now how do I find some legs? How do I find some values doing this? So using the tangent ratio, I'm still going to look from that angle. Now using our calculators, we can figure out what the tangent of 32 degrees is. It's going to be a decimal. So I'm just going to show you how to type that in first. So the tangent of 32 degrees, I type that tan, that stands for tangent, cosine, sine. Right now we're just using tangent. So I press this button that says TAN. Then I press 32 and I press enter. So the tangent of 32 is 0.6248, etc. Now when I'm calculating this, I'm going to use this tangent button. I'm not going to round this to 0.6. That's not very accurate. So I'm going to use that when I calculate. So for us to set up our equation, our reference angle, the one that we know, we are going to use the 32 since that was given to us. So I'm going to circle that. From the 32, the tangent of the angle's 32, is equal to opposite over x is the adjacent. So I have to use the opposite and the adjacent. Opposite goes on top. So that's 11 over the adjacent, which is x. Now I put it over 1 and I can cross multiply to solve. So x times the tangent, 32 degrees, is equal to 1 times 11. That's 11. Now to solve for x, I still have to divide both sides by the tangent 32 degrees. Divide tangent 32 degrees. So that is just a decimal that we're dividing by. That isolates our x because those will cancel. So when I type that in, I need to just press 11 divided by tangent 32. Notice it opened a parentheses. I want to close it because that's the end of it. And I get 17.603. So it's said to round to the 10th. So that's 17.6. And we have found a missing side using the tangent ratio. Find the value of x, round to the nearest tenth. So here we have a special right triangle, okay? So for us to find the value of x and round to the nearest tenth here, I don't actually see my x. It's already found all the sides. So I'm just going to talk about this in a slightly different way. So if I have a special right triangle here, in order for me to find the tangent, we're going to say find the tangent of 30 and find tangent 60. Okay? So that's what we're going to find. We're going to find the tangent of 30 and the tangent of 60. So in this triangle, if I look from the 30, the tangent of 30 degrees is equal to the opposite piece, which is 1 over the adjacent, which is the square root of 3. Now keep in mind, we said that we can't leave this as a radical in the basement, so I'm going to rationalize the denominator, multiply by what's down there, and I get 1 times the square root of 3, which is the square root of 3, over the square root of 9. And we can simplify that down to the square root of 3 over 3. And that is the tangent of 30 degrees. Now if I find the tangent of 60, I'm going to use a different color. So I'm looking from 60 this time. Opposite is root 3 over the adjacent, which is 1. So the tangent of 60 is just the square root of 3. And we got it. Okay? All right. Go ahead and hit pause, see if you can find the value of x on your own, and then come back and check to see how you did. All right, hopefully you had some success. So our reference angle here is 61 degrees. We're looking from that because that's the one I know. From the 61, 22 is opposite, have to use the x, which is the adjacent. So opposite and adjacent using tangent of the angle 61 degrees is equal to the opposite piece, 22 over x. Put it over 1, and we can cross multiply to solve. So x times tangent 61 degrees is equal to 22. Cross multiply. Have to divide both sides by the tangent of 61 degrees. And we'll see what we get. So we have to use our calculator for this. So 22 divide tangent 61, close it. And I got 12.19, so we'll call that 12.2. All right, on to the next one. We're going to use 56 this time because that's the one I know. X is opposite, 13 is adjacent. So the tangent, 56 degrees, equals opposite x over adjacent 13. Put it over 1 and we can cross multiply. So x equals, 1 times x is x, 13 times tangent 56 degrees. And then I'll type that in. So 13 times tangent 56, close it, 19.27, which is 19.3. And we have it. And 2 word problems here to wrap us up. It says you're measuring the height of a spruce tree. You stand 40 feet, 5 feet away from the base of the tree, and you measure the angle of elevation from the ground to the tree being 59 degrees. Find the height of the tree. So we're looking for h. So our reference angle is 59. H is opposite, 45 is adjacent. It's connected. So tangent, 59 degrees equals the opposite, h over 45. Put it over 1. Cross multiply to solve. 1 times h is h equals 45 times the tangent, 59 degrees. Notice I put the number in front. It's a little bit safer when I type it in that way. I could do tangent for 59 times 45, but I'd really have to make sure I close the parentheses. So 45 times tangent 59 degrees is 74.89. So 74.9 feet tall. Round that to the nearest foot, and we'll call that 75 feet. Said to round to the nearest foot. Okay? And the last one, you're measuring the height of a lamppost. You stand 40 inches from the base of the lamppost. You measure the angle of elevation from the ground to the top of the lamppost to be 70 degrees. Find the height of the lamppost to the nearest inch. So this really shouldn't be there. Cross that off. Angle of elevation from the ground to the top of the lamppost to be 70. So I am going something like this. Angle of elevation looking up is 70 degrees. I'm looking for the height h. I am 40 inches from the base. So this from here to here is 40 inches. So from the 70, opposite, adjacent, tangent, 70 equals opposite, which is h over 40. Put it over 1, and we can cross multiply. 1 times h is h equals 40 times the tangent of 70 degrees. Okay, type that in. And I get 109.8, so I'll call that 110. I'm gonna round up. And that's all she wrote for the tangent ratio. Have a good one.